All right, in example one, it says that the University of St. Thomas Geology Club has 14 students, and they want to select an outreach committee of 3 people. In how many ways can this committee be formed? All right, so you might be thinking to yourself, this sounds a bit familiar. If you watched the last lecture on permutations, we did an example very similar to this, only we were trying to fill the positions of president, vice president, and treasurer. In this particular example, we're asked to find a committee of 3 people. So what's the difference? What's the difference? Well, in the example where we're trying to fill positions of president, vice president, and treasurer, it makes a difference. The order matters, the assignment matters. If we make, say we make Ava president and Brett vice president and Evan treasurer, that's going to be different than Brett as president, Ava as vice president, and Evan as treasurer, or Evan as president, or Ava's vice president, and Brett as treasurer. Those are all different ways of filling those positions. In this case, it's just a committee of 3. It's just a subset with no order to it, and so it's different. All right, so in this case, if we have Ava, Brett, and Evan, then it doesn't matter whether it's Ava, Brett, and Evan, or Brett, Ava, and Evan, or Evan, Brett, and Ava. The order of those people doesn't matter. So it's very much like we're going to deal with it very similarly to the way that we dealt with the duplicate elements in a permutation, where we did those letter arrangements, right? We had duplications because those elements were indistinguishable. And in this case, for any given set of 3 people, there are 3 factorial ways to arrange them. If we count the permutation, so if we take the permutation of 14 things taken 3 at a time, that's going to count each arrangement of the people separately. Okay, so what we have to do is divide out those duplicates. So we have to think about how many ways do we have for any given set of 3 people? How many ways do we have to arrange them? Well, it's just going to be, say if we have Ava, Brett, and Evan, then, we're going to have 3 factorial ways to arrange them, which is basically a permutation of 3 things taken 3 at a time. Okay, so what we're doing is dividing out the duplicates. The permutation assumes that order matters. But in this case, and this is what a combination is. In this particular case, the order really doesn't matter, so we're just going to divide out those duplicates. All right, so the permutation is 14 things taken 3 at a time. So 14 choices for the first, 13 for the second, and 12 for the third choice. And then we have to take into account that the order does not matter. So we have to divide by the number of ways to arrange 3 things, which is just 3 factorial. 3 times 2 times 1. Okay, so we're just going to divide that out. So we have 12 divided by 6. All right, if I multiply that out, I get 364 ways to choose a committee of 3. Okay, as opposed to what we had before, which I don't remember what the number was. I suppose I could look that up. But when we chose president, vice president, and treasurer, it looks like we got 2,184 ways. Okay, so it's basically, well, it's 1/6, right, of what we had before, because for any given set of 3, the order of that set of 3 doesn't matter. Okay, but the permutation is going to count them as if the order does matter. So you just have to divide it by the number of ways to arrange that subset of 3. So what is a combination? Let's go ahead and talk about that. What is a combination? It is an unordered subset. An unordered subset. Okay, so here order does not matter. All right, so it's unordered. That's the key difference between a combination and a permutation. In a permutation, the order matters. In a combination, the order does not matter. All right, and we use the notation C and R, much like we use the P and r to represent a permutation. We're using a function c to represent a combination where the inputs are n and r, and n is the number of things that we have in the whole set, and r is the number of things that we're choosing in the subset. Okay, so we can read c n r, right? We can read this, we can say it's read the number of combinations of n things taken r at a time. Okay, so that's similar to the way we read the permutations. The only word that's different is combinations versus permutations, right? Now, another way that it's often read is just n choose r. So you might hear it called n choose r. Okay, so we're choosing r things from n. Okay, and choose often means combination where order doesn't matter. Okay, so in example one, we found the number of combinations of 14 things taken 3 at a time, right? So this is equal to C 14 choose 3. Okay, and so there's a formula. Now, what do you bet? I'm going to say, don't bother. That formula just makes it look much more difficult than it really is. Okay, I just want you to think it through. Think about it as a permutation. This is kind of the way I prefer to think about it right here. I think about it as the permutation, and then I'm just dividing out the duplicates by dividing by this r factorial. That's all I'm doing. And to me, that's a lot more understandable than this formula here. Now, I sort of I sort of derive that for you, but just think of it as the permutation, and then you're dividing out the duplicates by dividing by the number of ways to arrange one particular subset, okay, of however many you're choosing. Another way you could think of it as kind of the way I wrote it in example 1, which was C n comma r is equal to the permutation of n things taken r at a time, and then they're dividing by the permutation of r things taken r at a time, which is r factorial. Okay, so either way. So that's what I would prefer that you learn, because I want you to understand this. I don't want you to have to memorize formulas and then blindly put numbers into them. All right, so I will meet you in the next example.